Hey team, we're talking about this AI monitor system that we're building for integrated security systems consultants, ISC. Uh, so, so ISC provides security monitoring cameras, alarms, fire alarms, door access controls, and other electronics equipment. So we're going to work on the the infrastructure, and I'll show you how I actually plan on connecting to the data. This is something that I've already done, and I can show you a little bit more details of how that works. Like, this is how we connect to the Couchbase data cluster. So I have Python code here, and very simply, it runs to the Couchbase cluster with this connection string. Wait, hang on. Uh, that is that is not the right. I've got two. I'm looking at some other. So basically, you basically have like um, connection string. This is different. Well, it's still relevant, but this is how you do it in JS. In Node, if you're on Node JavaScript, you create this function that takes in the parameters, and then it takes in the host name, the API key, and then this runs. It creates a request, and it allows you to submit a request using HTTPS. If you're using Python, okay, this is a different project. This is actually the old Spotify API. Was importing a specific library for Spotify, and then you had to use this to download. You could download tracks and audio features from Spotify. That's not what we're doing. It's a similar idea, how you use an API to query information from some service. For like Couchbase, okay, this is the notebook I was working on. For Couchbase, you import, so you just start here, you import the library Couchbase cluster. Fortunately, there's already a library for this. In VS Code, I also have this extension here for Couchbase and Capella, and it even has this IQ AI thing that allows you to use like a productivity boost. You can chat with Capella IQ, our LLM AI chat service. It's a generative AI powered coding assistant that helps developers. Um, yeah, so you just write your queries like here. I'm writing the query in Python and then submitting the request. And yeah, it's um, like here's an example of how I can draw a graph in Python. And the data is coming from the cloud database in Capella, going into the Python, and then Python's using a library to create this graph. And this is where it actually lives. It's inside this cluster here. I have this table, which has these columns, and you can also run the queries like in your browser, which is also pretty efficient. And then JSON, JSON, or just tabular output. Um, Very similar to any of the other Python or any of the other like browsers. Like you'd have like Amazon Athena or Microsoft SQL Server. Except what's nice about Capella is that it has like all of these features built in. It also does indexing, so it helps you to stay organized and to manage the size and the computing resources. It also, I haven't tried this out, but it has search indexes. So it can search a vector, geospatial, full text search, and more for your applications. Use vector search support for generative AI, combined search types for hybrid. It also does like analytics, which I guess helps you make your queries more efficient. Um, And then it also allows you to save the query. Like it has these documents, and so you can go back and see what queries you've already run over time as sort of like a time machine, which helps you to tremendously if you're like trying to debug a query or you're seeing how the data changes over time. That's a big problem known as like data shift. And so when you can go back and see what queries you've already run, it's like extremely valuable for creating for creating databases. Mm. So I think this is something that we could look at, like integrating into the system. It does run with Amazon Web Services, and so yeah, so that's like those are the clusters that I've been um, playing with, just learning about the SDK. I've been uploading different types of data. This is an insurance data set. Um, this is customer data. There's some travel data. Uh, yeah. Um, and like um, Capella is like the cloud database. And then this columnar is this is the type of cluster that I have. Months to date, I've almost billed all of my credits. Yeah, so I was using a lot of credits around September, November, and then that was just doing some high EDL, uh, doing some really heavy workloads on larger data sets. So then my cluster was really scaled up at that point. But once that that project was kind of ended, and I don't need to use that heavy workload anymore. So now I'm just been using lower workloads. Um, so yeah, so when I'm done, you just go to okay. So then there's OpenCV, right? So OpenCV, well, Google Colab is a Jupyter notebook hosted by the cloud. And once you connect to a hosted runtime, it then gives you like basically a virtual computer that has some RAM and disk space. It gives you just 12 gigabytes of RAM, 100 gigabytes of disk space. Not that great, but if you update to the premium plan, you can get Colab Pro Plus, $50 a month. It gives you 400 compute units, a total of 500 per month, faster GPUs. Um, and with compute units, your actively running notebooks will continue running for up to 24 hours, even if you close your browser. So I've been looking through various data sets of security footage for research and development in areas like surveillance, anomaly detection, activity recognition. This data set uses scale in weapons. So the key features of Google Colab, it's pre-installed libraries. It comes with many of the popular Python libraries like TensorFlow, PyTorch, uh, OpenCV, and it has like just free access to start out. It also has cloud storage integration with Google Cloud, so your notebooks can connect to everything that's on your Google Drive. Um, it also integrates with GitHub, and then it's also a collaborative environment, sort of like a Google Doc where you can invite people to join the notebook. They can make edits, and everyone is running on the same machine. Um, I should say the photos or the videos might not be for sensitive viewers. Um, but so if you're not interested in seeing security footage that was used for like police training, um, then I guess it's probably not good to watch. But it's just like some um, some training that they did with these toy weapons. So the first step is to mount the Google Drive, and these are the video frames, and then like set the correct path to your frames, and then load the data, list the image files, load the images. Um, so and then so this is just showing that all these frames are successfully loaded. Here's an example of one of the frames. So this is like, yeah. So this is what the frames look like. You can see here's a camera, and there's some alleged um, criminals, people that are uh, being caught on camera. And yeah, so you can see the footage. And what we want to do is to have a way to detect which of these are harmless and which of them are harmful. We want to know which footage is, um, if it's a weapon, then we want to detect it automatically using a pre-trained model from Hugging Face. So we're using this Drift gun object detection model. It's a fine-tuned version of Facebook's DTR, Detection Transformer, Destro ResNet 50, specifically trained for gun detection tasks. Hugging Face, yeah, so Hugging Face is like this database or this model library where people store data sets and also models. And then researchers or people can access those. So the training data was fine-tuned, which included 4,666 images annotated in CCOCO format, which means, yeah, they already had people that manually went through all the photos and labeled them. And then when you import the model, you import this transformer, and then yeah, this is the type of model. So if we wanted to use like a car detection, you just import car detection model, or uh, a another type of model. Like if you wanted to um, recognize certain people, you could like upload a certain, like if you had a list of people that you knew were going to be in an office building, you could put their faces into the model, and then it would detect if it was that person or if it was a different person. That's something else you could do. And then we store the outputs for each frame. So we basically go through all the frames, and then you have to process each of the frames, basically put it through, and this tells you if there were any detections. So yeah, this is where you can set the model threshold. Many object detection pipelines apply a default confidence threshold 50% or higher, so detections below that threshold are discarded. Lowering this threshold can yield more but less certain predictions depending on the code of your model. You typically adjust something like that. So like here, I set the threshold to 0.15. If you set a higher threshold, it would detect fewer. And yeah, so you can see this is detecting the gun, and it's drawing a box around the gun in the same area. Now these images are not, the box should actually be around the gun, but the images that it's showing are not perfectly in sync. Um, but we can fix that. It is just a work in progress. Um, so if there was if there was someone on the footage that had a weapon, then this would detect that. And so yeah, so then you basically write this to a video. Let's slow this down. So here we can see like some frames. This person is carrying something in their hand, and it's most likely a gun. From this angle, it's really not 100% clear, but it is but it is likely. Like this frame, for example, it could just be his hand if his hand is in the right shape. Um, that's not a gun. It looks like he's holding a knife, but it still gets flagged as being suspicious. So then you can see here, this is accurately detecting the people that have the gun and also the gun. So yeah. So that's a good just a good test that we can use, like that I can use OpenCV and just using that I can effectively train the model using the resources that we have, using the computer vision technologies. It demonstrates that we're able to effectively detect weapons from camera footage and then label them effectively.